Right. So as per the first question, Putta, when you are going to throw a stone onto water surface, right, you are giving rise to a disturbance, right, in that water surface. So the energy, right, will be transmitted when you give out a disturbance. That is, in other words, a wave. So when you have a water surface and you give it a disturbance through a wave, right? What will happen to the wave, Putta? The wave will propagate. The wave will travel, right? So when the wave is going to travel, the energy will be transmitted. The energy will be transmitted. Okay. So what should your answer be? What happens to the energy of the waves? You have to tell the energy is transmitted. The energy is transmitted. Does this make sense, Muta?
Yes, miss.
Right. So what you have to understand is water is just minding its own business, right? But when you throw a stone at it, right, it has energy, right? So what's going to happen? It's going to cause a disturbance in the water. In other words, a wave. This wave is going to uh, uh, result in an energy transmission. An energy transmission. Suppose you place a paper boat. You have a paper boat here, right, on the surface and disturb the water surface with a small distance away from the boat. What change would you observe in the paper boat? Raida, what did you write, Puta?
It moves left. The paper boat moves left and right.
Come again, the paper boat.
The paper boat moves left and right.
The paper boat will move. I can't hear you. Your last word.
The paper boat will move left and right.
Left and right. Okay. Right. Any different options, Puta, about the paper boat's movement? Shafat, what do you think? Left and right?
Does it move up and down?
Up and down. That is the term I was looking for. Right? Now, Puta, imagine you can even do this. Okay. Take a plate and put some water in it, right? And place something very light in weight and cause a disturbance here. And you will see the paper boat will only move up and down. It's not possible for it to move this way, either. That is because in water, what kind of waves do you see? You see transverse waves, isn't it, Puta? So when the energy is being transmitted, the movement of the particle is always which direction? Up and down. It's the same thing in this scenario also. So what would you have to write there, Aida? You will see what changes do you observe in the paper board. The paper board will move
Up and down.
up and down. What does it illustrate? It illustrates that, what can you say? It illustrates that the particles of the medium are uh, oscillating only. They are only vibrating, right? They are only vibrating, but not traveling along the wave. They are not traveling along the wave. The particles are not moving along the wave, but rather they are using that energy to move up and down. But now, මෙතන මෑනිත් එකක් කියන්නම් පුතා. In sound, what happens, පුතා? The particles also move along the wave. That's why you saw the Slinky's compression areas. Understood, Puta? Particles also move along the direction of the waves. That is what parallel to the direction of the wave. That is longitudinal. Here, the particles are only going to vibrate, or in other words, oscillate, and not move along the not move along the direction of the wave. Does this make sense, Puta?
Yeah.
Okay. So, can anybody tell me the answer for the second one? What would you all have to write there? What does it illustrate? Illustrates that the particles in water do not travel with the wave, but only vibrates, or but only moves up and down. The particles of the water only moves up and down and do not travel with the direction of the wave. Does this make sense, Terunada?
Yeah, miss.
Shafka,
Yeah.
did you understand, Puta?
Yeah.
Okay, right. Let's go for the next question. Sketch a diagram to show what happens to the water surface. Right. So water surface එකේ මොකද පුතා වෙන්නේ? The ripples will be formed, right? Just like in the ripple tank, what you saw. So if you were to see from top, right? If this is going to be the place of uh, a disturbance, right? You will see from there ripples will be formed, right? Ripples will be formed. So if I were to see from the side horizontal view, it will look like this. Okay, and if here was the disturbance, if here was the place where the stone is thrown, the stone thrown, right? Here is the boat, because the trough and the trough and the crest taking place here, the boat will move up and down. Okay, imagine here is the boat, right? I push the surface from here. What's going to happen? The boat is going to get pushed down and then again down. So the boat is going to go like this. Does this make sense, Puta?
Yeah, miss.
Yeah. Okay. This is what you are supposed to draw. This is going to be the diagram. Okay. The stone and the boat is here. The ripples are going to get formed. Because of the ripples, the boat is going to go up and down. Sketch a diagram to show what happens to the water surface. Which type of mechanical waves do water waves belong? Which type, Shafka?
Transverse wave.
Transverse waves. Okay. In what way do the above waves differ from the sound waves traveling in air? What is the difference, Puta? So, air parallel yanne, මෙයා perpendicular yanne. නේද? That is what you have to explain there. අර අපි chart එකේ ලස්සනට බැලුවේ පුතා. So, if you were to write the answer, all you have to do is write this. In sound waves, in water waves, particles move perpendicular to the direction of the wave propagation, but in sound waves, the particles move parallel to the direction of the wave propagation. So you can write the definition in the form of the answer, giving the differences itself. තේරුණාද මේ ටික හොඳටම?
Yeah, miss.
Okay, Alhamdulillah. Right. Then